Hi, everyone. I hope everyone can hear me. We've still got people logging in, so we're just going to give it some time. Okay. Just checking who all are in the room at the moment. Okay. Okay. Just to introduce us also. So apart from me, so I'm Nikhil, and you'll also see Neha and Amar, who are my co-hosts on this stream. So in case anything like, obviously I'm going to be on air just and working with the system, so I might not be able to see all your chats, but either Amar or Neha will be on hand to catch all your messages. In case you haven't signed up for the free access. Okay, I'm glad you can hear me, Utkarsh. That's good. In case you haven't signed up for the free access, Amar will be the one you should get in touch with. He will give you a temporary account, but it's better to have a permanent one so that you can use it even after the system. We will reset like the temporary logins for the online system are only for this workshop. And we keep resetting them. So if you are interested in using the system even after, please do sign up and you will get that. Okay. Okay, there's quite a bit of people just signing in, so we're just going to give them some time. Okay. In the meantime, let me just make sure everything is ready. Okay. Let's get on with our session. And hopefully whoever else joins in can join in. I am going to use chat purely to paste links, but if you want to get in touch, you can select Amar or Neha, and they are the ones who will be able to help you out with any issues with the account. Okay, I'm going to start sharing my slides again. I seem to have lost. Let's go and okay. I don't need to share sound right now, so I'm just going to. Great. Okay. I hope everyone can view my screen. Okay. Got it. Okay, guys. So let's get started right away. First, before we continue on with the main topic at hand, just a little bit about the assembly. Many of you might be coming here for the first time. So the assembly is a smart lab and makerspace based out of In5, which is in Dubai Knowledge Park. I'm sure those of you who are situated around there would have definitely seen it. It's right next to the tram station. We focus on smart technology, and one of the main ways we do that is by engaging the community in workshops. So every week we try to do a free workshop for the community. Before COVID, we were doing it all live and on the spot, and then of course we were providing whatever materials were required to anyone who was interested in doing that. So It was a community outreach event, but we've taken that all online after COVID, and we are slowly going to come back to live workshops, but not just yet. So we are still doing these online. Our workshops are divided into a few different streams, just for the sake of categorization. We have assembly hack workshops where we work with embedded systems and IoT, so your Raspberry Pis, your Arduinos, your hardware. You don't need to bring your own. We always provide that. IoT, mostly like when we do live IoT workshops, obviously there is a hardware component also. In this case, we're doing an IoT workshop, but without the hardware component, depending on simulators. Obviously, it's all online. Assembly code workshops focus more on software. We try to focus on APIs and frameworks and apps and things that are more cutting edge. So we're not just going to do, vanilla programming languages and 101 sessions. We will try to show you the latest tools that are used. So code workshops get quite sophisticated also. Out of the code workshops, we've segregated assembly data science workshops where we focus on AI and ML. So today's session would also come under assembly data science. Our audience ranges from students to professionals to entrepreneurs and to anyone really. There is no age restriction or experience restriction. We try to provide enough sessions, enough material that even a layperson with some, obviously with the prerequisites, is able to do that. Our focus is on smart technology and, as I mentioned already, practical applications. So we want to build something, whether it's with hardware or software. You can find us on social media as Make Smart Things. So, in some places, if you look for us on LinkedIn and all, you can find us as The Assembly. But on Facebook, Instagram, as well as Twitter, you'll find us as Make Smart Things, which is our mantra as well as our handle. We have our own forum. You can sign up there to view past workshops as well as details and things about that. Our website is where we put all the online workshops, so you can see the past videos there. We have a very active YouTube channel also, so the workshops are also put up on YouTube. So you can just definitely take a look at those there. Currently, in the month of October, we're not doing any workshops because we are gearing up for GITEX. And GITEX is a big calendar event for us. We always participate in the Future Stars, and we have a stand there, and where our team builds different types of projects and presents it there. So it's a very big deal for us. So do come and see us at GITEX next week if you're around there. We will be in the Future Stars section, as will In5, as will Etisalat as well. The Assembly is launching a new initiative at this GITEX in combination with GITEX High Flyer called First Gig, where we focus on on connecting startups and students. So whether you're on the startup side or the student side, so do go to the site firstgig.org. It's basically to find internships for students, for bright students, to work with some of the best startups in the region. So do check that out. It's at firstgig.org, and you can definitely find out more about that there. And please feel free to ask any of us here if you want more details. So I'm going to, since again, I figure a lot of people are new. Okay, somebody else has just joined in, so. Okay, so since a lot of people are new here, I am going to cover the basics of analytics. So we did a analytics workshop about 2 to 3 months ago. And we were focused on predictive analytics, and we were trying to work with real world data, and we covered a lot of ground there, but I'm not going to go over it all again because obviously we have issues of time, but I will cover a few of the things, and I do still have some of the slides here from there. So I am going to cover that, so just so that you can understand what's going on before we delve into specific area of time series data. Time series is something that is a very big part, but we left it out before, and we wanted to do a separate workshop, so that's why we're doing this here, but we will also do a recap of what we have already. Okay, so just in terms of just the theory part of it, there are 4 types of analytics that people always talk about. There's descriptive, diagnostic, predictive, and prescriptive. So these are analytics that can be conducted on different types of data to produce decisions that we can take action on. So you can see the different levels of those, and they do different things. Descriptive analytics just basically look at the data and get maybe statistics and things and say what happened. We will use a little bit of descriptive analytics in our system, but our focus will be more on predictive. So what will happen? So how can we predict values and do things? So diagnostic and prescriptive, there are features in ThingWorx for prescriptive analytics as well, but we're not going to go into that at this point. So for decision support systems, of course, you do need prescriptive, but we're going to focus in on predictive analytics. And the same holds true whether it's like time series or non-time. So what is predictive analytics? Again, what we're focusing on. So predictive analytics applies machine learning to historical data, of which there's a wealth of when we have IoT, and makes predictions about future outcomes. So now, thanks to all the advancements that we have in machine learning, it's easy to factor that in. And with all the historical data that comes in from IoT things. So if you're doing this workshop, if this is the first time you worked with ThingWorx, so a thing model is a representation of data on the edge devices in the cloud. Okay, so a thing model is the data we are working with. So it's a raw data we're working with. This could be maybe, for example, it could be sensor information. If you are if you have a heat sensor on or something that is measuring, could even be like something measuring time. So if all of this is happening on the edge means it's on the remote device and it is being pushed onto the cloud and twinned. So that is being stored by ThingWorx as a thing model. So that is our base data. That's our historical data that we work with. ThingWorx also provides something, an analytics model that takes that and applies some logic to make predictions based on that. From that logic, we are able to get insight. So for example, they've given something here where it says that, okay, this is the predicted status for this value. So it could be, based on all the device sensors, you could predict when it's about to fail, or if some error is happening, or can we expect, is it working properly? All these things can be predicted rather than just say from observing. So thanks to machine learning, we can do all that. So we have a few example cases. Of course, you can predict failures of devices. Of course, that is one of the big game changers with analytics. Previously, when machines used to go down in remote locations in factories, it would require somebody to come there and fix it. And all of that is very cumbersome and time consuming, and it relies on it actually failing before you do anything. But with this, you could predict the failures before they happen. You could predict degradations in quality. You could predict, how to improve quality. So all of this helps and makes us more efficient in all our scenarios. You could predict sales. So you could do things like, once you have the different information, once you have churn information coming in, like the risk of churn, losing, customers, all can be done in advance, and you can determine when service is required for a device. So there are many different things you can do with predictive analytics. Again, this is stuff we covered in the last session, so I'm not going over that again. Focusing in on ThingWorx Analytics. Now, ThingWorx Analytics runs as a separate module, and you can see a lot of things there. The ThingWorx Analytics runs as a server module. It's basically a microserver. It's a separate installation from ThingWorx Foundation, which is what we've used and what we've installed. So out of the box, you do not get ThingWorx Analytics server with ThingWorx Foundation, where you model all your IoT data. So Analytics Server is a separate installation that works on the same Apache system, and it consolidates a number of microservices and components expanding on ThingWorx Foundation. So we don't need to get into that. We've got the Analytics Server installed, but ThingWorx Analytics is a separate component. You should know that in case you ever get to working with that. Analytics API is a primary method of communicating with these microservices and services. Analytics API, there is a lot of documentation of the support.ptc. You'll see everything there. ThingWorx also has built something called an analytics extension, which is an extension to ThingWorx Foundation that allows you to interact with analytics directly. We've used this before, but I will show you what that is as we go on. So this adds tabs to composers, which includes builder and manager. Those are the two components that are added when you add the analytics extension. So you will see a tab which shows both analytics builder and analytics manager, which is what we're going to. Analytics builder generates models in PMML format. That is the reusable format if you want to export, and you can do that. So that is our standard format, like XML, for example, or something. PMML is a machine learning specific format, and manager allows you to operationalize models. Operationalize, I will tell you what that means, but that's how you can actually apply it to live data. So rather than just building a model in theory, you can actually apply it to real-time IoT data. And we will cover what we did last time in terms of both building and operationalizing from last time. The analytics extension is just a collection of web mashups, really. So web mashups we've seen in previous sessions, they just built within the ThingWorx platform and just wrap around the API calls and allow you to use them more easily. This is, of course, a very detailed diagram. You don't need to look at, this is actually the, you can see the different architecture if you wanted to really look under the hood. So you can see Zookeeper, that's all working on microservices and database. So that is the server where it's running different worker threads and how it communicates. You don't need to worry about this. This is very detailed, and this is only something a ThingWorx admin would really need to worry about. So coming back to what we are going to be working with, we've got builder and manager, right? Okay, I see people are still joining, so I'm going to just give it a few seconds. Okay, so we've got builder and manager in ThingWorx, and this comes with the analytics extension, and you'll see it in action directly. So I'm just quickly running past this. As I mentioned, building the model is done in builder, as you would expect. So builder takes the data. ThingWorx Foundation is the part of ThingWorx that we're used to, which contain things and all the different stuff from Composer, which we are able to access. We've used many times in the past. Builder takes, sits on top of ThingWorx Foundation and builds a predictive analytics model using various properties with the input data. And then once it is there, once you're satisfied with the results, you can publish the model to ThingWorx Analytics Manager, right, which is also all configured through this. Once you have built the model, you want to operationalize, and that's what you use ThingWorx Analytics Manager for. ThingWorx Analytics Manager will contain your model, and any data that is on ThingWorx Foundation will be sent over there to make predictions, and these predictions will be sent back to the thing. So you will have your normal vanilla things in ThingWorx Foundation will have data that it will push to ThingWorx Analytics Manager to a published model. It will retrieve it will retrieve predictions from there, which will come back and fill values. So we will be doing this hands-on, so don't worry if you don't understand this right away, but that's something. So just a bit about prediction models also in this thing. So technically it takes historical data. As is usual, the default case is 80% of the data is kept for training, and 20% is held back for validation. So when we're building a model, so you obviously need data to train, but you also want to hold back some data to validate. So if you have enough data that you ideally do want to hold back 20%, you can change those numbers, but by default it is 20%. And this is again the same. The way models work, so ThingWorx uses ensemble techniques. So you have different, many of you, if you are familiar with machine learning, you would be familiar with some of these terms. So linear regression is the most basic. Logistic regression is used for classification. You have things like decision tree, which partitions the data for classification, especially it's used. So these are all well-known machine learning techniques, and they all have different applications. You also have support vector machines that's not mentioned here, but those can be used with Boolean data. And of course, you all know about neural networks. Neural networks have multiple layers and work with, so those are probably the more complicated versions of that. So ThingWorx supports all the basic machine learning models. And the way it works in terms of an ensemble technique is, by default, it will run 3 or 4 different methods and pick the one that gives you the best results, and automatically, without you having to intercede, select those as your primary model. And once that's done, once it validates and it gets all the things, you can also optimize on your own. That model is ready for production, and then it can go to Analytics Manager. So you also have, like I said, neural network is one of the more complicated, but you also have even more complicated ones like random forest, which is like decision trees, but multiple random decision trees rather than just say, something that is prepared. So if you have ever done any research into machine learning, you would know about this. Gradient Boost also works with decision trees, but it's like multiple sequential decision trees. So these are all great methods, and they're complex, and they do fit sometimes well, but they are also slow and can also lead to overfitting. So they might not necessarily be accurate as well. Okay, so this is just a little bit of a recap, so that I think everyone has shown up, whoever is on that. Just a little bit of a recap of what we did with prediction models in the past. Now, we are going to focus in here on time series data. In the past, we worked exclusively with non-time series data, and time series data is a thing. So I think it's quite self-explanatory, but in case you haven't got that, time series data means it's a sequence of data points observed at regular intervals of time. So it is chronological data where the sequence does matter. Okay, and the sequence and the trend. So whether some data has been like, whether data point happened yesterday or happened 2 years ago makes a difference. Normally when we work with machine learning algorithms as well, and when we've done predictions, we have a range of values, and based on different fields or features, we predict a certain value. So in the example we had before, we had and we'll look at that again, we had like compressive strength of cement. So we had different inputs like super, what's the amount of fly ash, what's the content of different ingredients. And based on that, we predicted the compressive strength based on values we already have. Their order did not matter. It did not matter what was the previous value of compressive strength or something. It was just asynchronous, you could say. And those are easy to handle. And those are also easy to handle for machine learning because you can directly apply these algorithms. When you have to work with time series data, it becomes a little more complicated. The data needs to be transformed before being used by machine learning algorithms. So the data cannot just be in a structured format. Even if you have the timestamp given there, it can't just be used that. The way ThingWorx uses this is by windowing it automatically. So it pivots the data based on the history. You can specify the window size, and then it actually pivots the table, so it adds extra fields saying what's the n-1 value. So say at the previous time checkpoint, at 2 previous time checkpoints, at 3 previous time checkpoints, these become the features for your model. ThingWorx handles all this implicitly. You do not need to actually transform the data. Normally, if somebody told you that, okay, I have a set of data, this data, and it's got a timestamp, you would have to do this if you wanted to make predictions based on n-1 or n-2. ThingWorx takes care of it automatically by windowing automatically. One of the important things is that the data that you feed into ThingWorx is a little different. And again, this will all make sense once you see that. So in fact, let me actually just also share one of my, have I got the screen up? Okay. I'm going to also share my screen so I can actually show you a few different things. I did save a few. You can actually see, the article is shared there, and I will definitely share. So there are a few steps, and I definitely urge you to.
We can't manage work like this. That's why I use Monday.com. Okay. My team uses it to manage projects, sales, recruitment, everything.
You've got an ad showing, so
you
can ignore that.
1 minute into the future, what happened to you?
Okay, I'll show you the video later. I wanted to actually just show you how ThingWorx Analytics works with that, but we can see that all later. So there are nice articles, like I said, on PTC. You see a lot of different things, where you can find out like how to. Okay, I need to log in for this. So this is the PTC again. The portal where it mentions everything. And there's a lot of support here, so you can definitely get into that. So it tells you like, how you can handle. So it gives you these are the important points. So the data set that you handle has to have a field for entity ID, which says, which is how it segregates in case you have data for multiple, say you have multiple devices in the same data set, entity ID is necessary to identify which one you're doing that, because obviously they will have separate things. And you need a temporal ID field, which indicates the sequence. So these are all important, and you'll see that once we actually work with that. You can look at the video that I've mentioned on there. I'm just going to go back. So I hope everyone can see my screen again. Okay, so the mandatory fields, as mentioned, that you need for entity ID and temporal, you can actually look at the the YouTube video there to see the best practices. Now there are 3 properties when setting models for time series that are important. Okay, one is lookback size. Lookback size is basically the size of your window. So you're saying how many steps behind in historical data to go to. If you set it to 0, ThingWorx does auto windowing. So in which case it will run a few, and this will be slower. Obviously, it'll take windows of 0, 2, 4, 8, 16, all powers of 2, which again is also recommended when you're selecting your lookback size should be a power of 2. It'll automatically take that and pick the best one, the most accurate one, and do that. But of course, it will take more time to select. So it's better if you set your own lookback size rather than leaving it at 0. But if you have time and you want to see the best options, you can definitely leave it at 0. Look ahead is how many steps it's predicting. By default, it's 1, but it can predict more than one step ahead. So it can predict more than one value. Now, use goal history is really interesting. Use goal history is calculating, and I'll explain it to you a bit more. You should set it to false when you do not want it to calculate intermediate goal value. So your goal value is the field you're trying to predict. So for example, in our case, it will be, a pump's water flow. So a pump's water flow, we are predicting. If we have that value, it's useful. Like then you would have used goal history as true. But if you are working with a virtual sensor where it doesn't really have intermediate values, you can set use goal history to false. And setting use goal history to false will only calculate based on the window, and the pictures in the next page will make sense. So I will explain that. So this is with goal history. So you can just look at this, and this will give you an idea about everything. Your goal field here. You are trying to calculate G3, which is at the third time interval, right? So G3 will be predicted based on all these values. So if there are two features, A0 through to A2 and B0 through to B2, and as well as goal 0, goal 1, goal 2. So these are the intermediate values calculated, which are also calculated on their own window. So it's a sliding window. But G3 will be based on values from all of these. When you have to calculate G4, it will also take into account G3, which you predicted last. So this is an example of how the data is pivoted. So like I said, it pivots it and it shows features for each of those values. So normally, instead of A0 and B0 being in the entry, it's put A2, A1, A0, B2, B1, B0, G2, G1, G0, and G3, okay? So this is how it pivots the data opaquely. So this is all happening under the hood. You don't need to understand this necessarily, but it'll help you when you are looking at different parameters. This is how it works when you set goal history off. So when you set it off, and this is very important, there's one particular use case that you need for time series when it is, for example, when you want to predict time to fail, okay? You don't have intermediate failure values. You only have like one failure value at the end. So in that case, you don't really need goal history. So here you can see there is no G0 or G1. It's only using the window from the features. Same way here, and it pivots less data. So in a way, there's less data also involved. So this is what happens when you turn goal history off. So just coming back to the time series, I'm just actually going to come back to, before we go on to this. So coming back to the time series thing. So where are the examples? Okay, let's first look at what are non-time series, examples. So where it's not order independent, as Ready for Analytics is. So for example, if you were to run an algorithm to predict a patient's chance of catching heart disease, okay, there is no temporal data. There's a set of values that you have, and you might do that. You could obviously, anything can be transformed into time series, but you don't necessarily need that. You could have a set of data which says this is the person's different things, and then it predicts a value for each row. So you would have different features, and you would predict one value. How much a used car would sell for, so it would be different sensor readings. What is the mileage? What is all that? You could again do a time series also, but you don't necessarily need that. Where you definitely need time series would be like something like where you want to predict stock prices. So it depends on the values beforehand. The most important example, and which is something which we are going to show you, is when you are processing signal data streams from sensors. So IoT in general has a lot of historical data. Data keeps coming in, and that's all recorded. And you want to process the values that happen in the future based on past values. So in case values are degrading, in case values are enhancing, you want to be able to do that. So time to failure, as I already mentioned, is an important use case, as is, like, say, maintaining inventory. So you've understood the three parameters: look back size, look ahead, and use goal history. I am again going through this really fast because we need to do this. We will be doing it hands-on, and you will understand a bit more there. Just a bit before we get into our online cloud access, when we work hands-on, you've all been sent the link. If you had signed up for an account, you have a username and password. You need to take this link and enter it in. You need to enter that username and password, and it will redirect you to a web app, which is ThingWorx Composer, that we've used before for ThingWorx Foundation, but we have an analytics tab also activated there. A couple of rules that you should remember. Please, since we're on a common sandbox, please do prefix or suffix all things with some unique identifier. It could be your initials. So if I create a thing there, I would suffix it with _NS, which are my initials. You could do the same. As long as it's unique, because we are creating on the same sandbox, there will be issues. So be careful not to edit or modify objects. It will raise a flag and it might not allow you to if it's locked. But please, do be careful with that and try to only work with objects that you've created yourself. The other thing is all your data is going to be preserved here after this session, but at some point I will reset it. So please, if you want to take a backup, you can always persist data by exporting. You have export permissions here. If you want, you can export the data and import it into ThingWorx has a trial server that it allows you to use online. So you can definitely use that if you're not able to access here. You can save the data, you can import it back in. You will have access to this server also afterwards. Okay, so that's just a little bit about the online cloud. I do stress this a few times. We've had it a few sessions now, but this is important. Okay, what data are we going to use? We're going to primarily focus first on some, and this is an interesting one, and I do want to make sure I share this. So we're going to work with, predicting future water flow. Water pumps are a very good example of, setting it up. In fact, I've got a nice little use case from the ThingWorx where they work with a company called FlowServe that has water pumps, and it shows you how useful real-time analytics are. We're going to use slightly less. We're going to be working on predicting water flow based on our model. So that will make it. And the second data set that we will use is it's just a simple univariate. So it's just got one variable. It's taken from a live data set, like it's an actual one. So it's real world data from a physics lab experiment. The laser, just has a laser value, and we're going to predict the laser value, and we're going to operationalize that data set. We're not going to operationalize the water pumps one. I'll just show you the thing in the background, and you'll get an idea. So there are also additional data sets which I will upload. So all these data sets you do not need to upload. We're all going to work with the common data sets. So I'm just giving you the links. You can access all this data if you're using it. You do not need to upload this data on the server. I will have uploaded it already, but you can access all of that on ThingWorx-serve.theassembly.ae/time-series-data.zip, and you can use this, of course, outside also. All of this has been curated and modified from either developer ThingWorx or community PTC. So please do take a look at those also. I've got a few, like I said, a few additional data sets, and you can try those after that. We won't have time in this session to do all that. Okay, so first thing before we get on to anything, let's have a look. By the way, one more thing. So ThingWorx-serve.theassembly.ae/time-series-data.zip is the data. You will also find there's a file called time-series-workshop.pdf, which is this particular presentation. In fact, I'm just going to put it into chat. So, sorry, I'm just typing that out. The assembly.ae/time-series-workshop.pdf. So this location, I put it in chat as well. You can use this to to see all the info in these slides. So I put it up as a PDF. Okay, so please do get that. If you want to get all these links, you can get it from there. Again, like this data, you do not need to download it for this session, but if you want to use it in other cases, if you want to use the trial server, if you want to install your own version of ThingWorx, you can definitely, even as a trial version, you can use it on there. Okay, so I think that's about it. Let's go over to this. I wanted to show you the video first, so I'm going to do that. Let me go back to my data, sorry. And I'm going to actually, let me just click through from here. So I wanted to show you a video on this from the ThingWorx site. And we're not going to see the whole thing. I am going to make sure I share my. And I'm going to go a little bit further. So there is a bit of stuff before that we can skip, but you can definitely have a look.
One of these pumps goes.
So this shows you the
protect the flow of materials. Take a look.
That work.
FlowServe is a leading manufacturer of flow management products. Their pumps help move, control, and protect the flow of materials in critical industries around the world. If one of these pumps goes down, the costs and lost opportunity can run into the millions. This rig uses a FlowServe pump, similar to those used in critical industries to circulate water. It has been retrofitted with 6 sensors provided by National Instruments, and a high-performance computing solution from Hewlett-Packard Enterprise is enabling analysis of the data. ThingWorx machine learning allows you to know more, do more, and get more from a machine like this. What you're seeing at work here is the automated edge sensor analytics technology behind the platform called ThingWatcher, part of the ThingWorx Analytics capabilities. Each sensor reading that has a learning flag above it tells ThingWatcher Analytics to learn normal operating conditions. Remarkably, the automated process does not require you to predetermine any hard and fast rules. It learns in real time about its environment. Determining what's normal and abnormal from the sensors themselves, the software then correlates the information with peak efficiency conditions. The OK indicators you see here tell you the sensors have learned what normal is and are functioning well, with no anomalies detected. To the left, you'll see future predictions, 3 outcomes predicted by the platform's Thing Predictor technology. The automation you're witnessing real time is ThingWorx Analytics evaluating the remaining number of days until each of these failures is likely to occur next. What's truly extraordinary about all of this is that there is no need for anyone to be constantly monitoring the machine. It is instead being self-evaluated all the time at a rate of 30,000 readings per second per sensor. We've turned on the pump rig to demonstrate what happens if something changes or goes wrong. Well, let's make a few things go wrong on this pump to show ThingWorx Analytics working in real time. We're going to simulate a reduction in flow by closing this valve. As you can see, the software immediately responds to the change of flow. What's happening is that ThingWatcher is automatically detecting the flow problem and sending real-time notifications or alerts. Critical sensor readings are being flagged, pump efficiency is dropping, and the impeller is at risk of failing if the problem is not immediately addressed. When maintenance is delivered, the numbers return to normal. So as you can see, the problem can be resolved before it becomes an expensive pump failure or serious downtime occurs. Let's throw another problem at the system and see how it works. I'm going to shift the alignment of the pump by lifting the main housing through the pull of this black bar. You can hear something is wrong. But let's imagine a remote monitoring situation and there's no technician around to hear this. So you need to rely on real-time monitoring. ThingWatcher is reading anomalies to flag negative changes to the pump efficiency gauge, which immediately triggers. The system can also simultaneously send an automated phone call to a technician, alerting them of the problem. Once the problem is resolved, the numbers return to their normal state. You can imagine the level of control and visibility this technology can provide within your central fleet, offering an incredibly responsive view of the usage and condition of pumps all around the world from one location. This demonstration featuring PTC's Predictive service solution is just one example of the hundreds of ways the transformative power of machine learning delivers value. Through that power, the ThingWorx platform enables unprecedented access to connected intelligence synchronized to your machines. A platform of data analysis and systems learning delivered with utter simplicity.
Yeah, so that's just I just wanted to give you an idea of how powerful it can be, and obviously some of the things that are different there, Thing Predictor and all. Some of these have been superseded, but the terms are different. But this just shows you how it's used in industrial IoT as well. So how you can put machine learning analytics into life. So I'm going to just close this. In fact, let me just stop sharing, and I'm going to just come back into here. So I need to just give me 1 second. I'm going to log into my system. Probably lost connection there. And then I'm going to share my screen again. Okay. Let's share my whole screen. Okay, I no longer need to share sound since we're not going to be watching any more videos, but okay. So what I'm going to do now is like, now we're going to focus on the hands-on part. I hope everyone is like, when you go to ThingWorx-SRV, so I'm just going to do that just to, you would get this screen and you would get a sign in. I hope everyone who's on here has a sign in. You would have a different login, and you can use this login, like I said, even after the session. So it's very handy to have. Let me make sure I'm signed in. Once you do, it logs you into ThingWorx Composer. Now, ThingWorx Composer, even if analytics didn't exist, ThingWorx Composer would also already have all this data. So this would be what you would see. Yeah, so ThingWorx, has like, it groups things into like, projects is a logical view. So we actually use the project view as we've done before. We've created something called assembly project. How you set your project is just a way to logically associate, because remember, it's a multi-tenanted system. So different people might be using that. So you should, set your project context if you haven't already. But we don't need to worry about that in this session, because we'll be doing a lot of different things with that. So everything is managed from here, from users to things. So we've seen things before. Last time we did, in fact, like when we did the medical workshop, we created things that were like logical, like MDSD was like medical device. And, we created data views which had like, properties that are taken from edge devices. So like an MRI machine has a number of scans property, unused RAM because it is a computer still. So things like that were all stored here. So our things have properties as well as services which help us in here. So you can just think of them as like objects in programming. So they are like, kind of data models that we use for that. But we will come back to that in a bit. What we want to look at first is like, once you activate the analytics extension, you get this extra tab here showing you analytics. Okay, and you'll see analytics builder and analytics manager there. We've spoken about those, both of those. So these are separate. Now, analytics builder is where you want to start, right? So you want to go in first with your, with getting your data. And just quickly, in 2 seconds, I'll just show you like some of the past examples we had. So we had worked with, like in the last session, we had worked with engine vibration data, espresso machine data, and concrete data. So I'll just show you what this, so this is like the concrete data set that was installed. It was just a CSV file, an Excel file, which was just ordered rows, and we imported it in here. This is where you import your data. We created descriptive analytics for it in the form of 2 things, signals and profiles, which gives us some information about the existing data before you make predictions. So signals, which we had looked at, like, again, these all based on, so like we created concrete signal. It told you which fields are most influential in making predictions. So it said cement, water, and age are the 3 most, 3 most important features that predict your compressive strength goal. So compressive strength was another goal, which we had values for, but we wanted to predict in our model. So this gave you some description of how the data set influenced the goal. Profiles are similar to signals, but instead of individual fields and features, it gives you combinations. So it says, like in concrete, not only does it say that age or this is the most influential, it tells you which fields. So it says when age values are between 55 and 110, and water is between 134 and 190, and cement is between this, your average goal value was predictable. So these were useful values. So it told you that these influence. So these gave us an idea of which fields to use, which features to exclude, because you might not want to use all features. You just want to use the ones because your model will get more complex. And of course, under Analytics Builder, models is where we are. So you can directly go to this step. You don't need to do the signals and profiles. Those are just to improve your models. So we had created last time, so everyone had created different, so the users had created individual ones, but this was the one I had created. So you can see the model. Again, models will differ based on the type of data. Is a compressive strength is a continuous data. So it is a value that is going on changing. It is not a categorized or ordinal data where it's like a discrete value. It is something that can go on. So this is the model. So it divided it into training, and it's not a Boolean also. We've seen Boolean with where you get ROC curves and things. So that's a different thing. But with with compressive strength, since it is a continuous value, this is the training metrics that we got. So it splits it into, remember, 80% 80% of the data is used for training and 20% for validation. So this is fairly good. We got 91.22%, which were within the range. So this is good. Like, these coefficients, the RMSE was pretty good. The Pearson correlation was also quite high, which should be the case. Very few things fell outside. There were a few that were over predicted and under predicted, but most of them fell within predicted. So this is good training metrics for our data. And when it validated, also the validation metrics also showed some good results. So you had like 83.5, and some variation is there, but these are good results. So you can see, like, so we had passed some parameters. If you want to see the model configuration, these are the different things that we had done. We specified our goal field as compressive strength. We just use the default. So these are learners are the individual machine learning methods. Like I'd mentioned, decision tree, gradient boost. And again, it did it as an average of these. So it took an average of the best methods that gave the best results out of these, and then took averaged out the values to give you your final reading. So this is all under the hood stuff for models. Again, this we did in the last session, so you can definitely look up the previous session. Model details are actually like details of what was created. So the model fields, we use all the fields from the data: cement, water, superplasticizer, coarse aggregate, and age. And this gives you some stats, also the distribution statistics for the goal based on the other values. So you can see all of this. So it gives you everything, but then this model is related. So this was all done in Analytics Builder. After we did this in Analytics Builder, that's when we went back to the model and we published it. So you can go if you go back to the model thing, you can see a list of all the models that have been created. And we went here and we published it. Sends it to Analytics Manager. And when we were able to do that, like in Analytics Manager, once you publish a model, it shows up with a particular thing here. So this was a published model. This was the one that's published and enabled. So you can see enabled here. Publishing the model allows us to use it in the rest of ThingWorx. That's what you need to remember mostly. And we set up an event for a thing called concrete data thing. Right? Okay, and this is not enabled, so I'm going to enable this analysis event. So it says whenever the data change in concrete data thing for any value, but cement, for example, then we were populating values. So if we go back and let's have a look at concrete data thing. Again, you can always browse through anything. There are different ways of accessing things here. Everything is autocomplete. So if you go here and you just search for concrete, it'll show you the thing automatically, or you can go through the list and just go on to there. So this was our concrete data thing, which is holding values. So you can see here, since I have actually, let me do one thing. I'm going to turn off the event. Actually, no. So the event is, so you can see actually that these are the values that we were simulating. So we have simulated using a subscription here. It's just populating with default values. So we have a JavaScript function, where we're just filling it up with random values. We're just for cement, water, age, and superplasticizer. So this was just used to generate these fields. So you can see cement, coarse aggregate, and all are changing every interval. But you will also see these two fields, result _ compressive strength. This is coming from a machine learning prediction from our model. So all these values are these particular values, fields are being passed to our engine, and it is returning a compressive strength value, which is being stored in this field in the same thing. So this is an operationalized model. And you can even see we had created a mashup. A mashup is just a web app, as you know, that shows all the data. So you can definitely see the mashup as well. So this mashup is like, you can see it's refreshing also. It was showing both the values that are being simulated as well as being predicted using the prediction event. So this is a fully operationalized model, which is taking any cement, water, age, coarse aggregate, and superplasticizer, the 5 features we have, and giving you a prediction. But again, this is not a time series because it's is taking these values without any timestamp, and it is giving you one value, one prediction based on that. There are other things we also looked into, like a confidence range, which tells you what's the maximum error and all that, which we all seen that. You can see that in the past workshop video as well. So I'm just going to close this. So that was just a recap. I just wanted to do a quick recap of what we had done before. So I'm just going to close that. That's enough for that. And I'm going to disable that event, because remember, all of this is happening on the same server, so we don't want it necessarily running at the same time. Okay. So let's come back to our data. Now, I wanted to show you the data from, and yeah, don't worry about this. This is just like Windows Explorer. It's a two-pane thing that I've been used to. And this is the data set we are looking at. Okay, we're going to be using this water pump data. So there are two separate files. The metadata is stored in a JSON file. We will look at that also, but we also want to look at, there are two separate ones. There's water pump train and water pump score. Score is a much smaller set, which we'll be using to see the results, but we'll be using water pump train. So this is our data set that we've got, and like I said, and this is the structure, which you can see. So all of them have to be, like, what's different with the time series data is there have to be two fields which contain, like, these two op types have to be there, entity ID and temporal, right? Temporal also has a time sampling in the interval, which says in milliseconds, how many seconds is the difference. So it says that if your row says, if you look at the data again, so you can see your temporal field is here. So the difference between each of these is just 1. So that is specified by this time sampling interval being 1. So if I specify time sampling interval as 10, the difference between each of these would be 10. Okay. And again, water pump ID is there so that it segregates. If you look at it, there are different water pumps. So this is the water pump ID refers to, oops, I don't want to do that. So it refers to a flow serve pump in the shed. But if you look at other sets, there's like 10, which is a flow serve pump in the warehouse. So it's a different entity. You don't want to mix up the time series for that, even if the data is mixed up here. An outside pump of the brand Condor has ID 2. So it separates all these out. Okay. The numerical values are what are important to us. And, that's where you have to see. So you've got lubrication level. These all could be any properties on there, water pump pressure, etc., vibration, kilohertz. These are all coming from different sensors. And our goal value is water flow. So we want to predict water flow based on past water flows. Okay. Without time series, you could do this. You could predict water flow based on these different features. But we want to predict it not just based on these different features, but also on past data. So that is something to keep in mind. Okay, so I'm going to come back to my data. I'm going to upload my data. The first thing I want to do is, I'm going to just call it, just go to, I'll just do that slowly. So you come back to Analytics Builder, you go to the Data tab, you click New, you have to give it a name. So I'm going to just call it Pump Data. You choose the file in your CSV format. I'm just going to take that same one. Make sure you, in case you're doing this on your own, make sure you take the one which is the train file, which is the larger file. And you also need to upload metadata, which is in our JSON file. So that is waterpump.json. Again, you don't need to do this. I'm doing it centrally, so the server contains all that. After you do this, you need to check on review uploaded metadata, and you need to select time series data. So it's a separate use case that does that. Once we hit submit, it will be getting the data. It tells you this is the data which it gets from the JSON. We can just continue on that. It's got temporal fields, it's got entity ID fields, which is fine. And then we can just create a data set out of that. This creates a job on the server. So it can happen, like I could close this window and it would still go on in the thing, and it'll happen at the same time. Now our data is into the system, and it gives us that. One thing to note, you cannot create signals for time series data. So if I go to signals, and I go and I try to create signals for, if I say go and create signal, go and create a signal for pump signals, and I say data set is my pump data, and I select water flow, and I do this, and I say submit. It will create, but you'll see once the values actually go, it will say time series data is not available for this. So anyways. We'll come back to that. So that's the other thing, because it's a server-based system, we can create profiles also. Profiles work with time series data, so you can definitely do that and try it out. It has created it. Yeah, but the last time I tried creating it, it did that without. So I'm not sure if that works. Well, it gives you some data. Anyhow, we're not interested in the signal, so we don't have to worry about that. Okay. Coming to models, that is where most of the work gets done, right? So we want to go and build a model based on and all of you can try this separately. You can create an individual model. So you go to new, you give it a model name. I'm going to call it pump. Oh, sorry. I'm going to call it pump model _ns, just to differentiate in case any of you are using it. You select the data set that you want. I want the pump data. By default, it'll pick any goal field, but we don't want water pump pressure. We want water flow as a goal data. The filter, we don't want to exclude any fields. You can also exclude some fields if it will make it faster. So you could exclude, like, say, the other fields. But for the purpose of this, we will just leave it on, leave all the fields in. So you could exclude data. You could exclude rows. You could create a filter so that it excludes rows with a certain value. We're not going to look at that. We're just going to keep that. You see this is automatically checked on because it knows it's a time series data configuration. Advanced model configuration is where you put in the values. And remember, now we talked about all the time series parameters are here. Some things that we used previously for Boolean goals are not available. You can but we're just going to use the default. There's no reason to change that, where it'll it'll try a decision tree, it'll try a gradient boost, linear regression, neural net, and it'll pick the best and it'll take an average of that. We're going to change, okay, I can leave lookback size as 0 here, but that will make ThingWorx go through different options. So it will be slower. It will already be slow because it is, of course, window data. So I'm just going to keep a fixed lookback size of 8. It should be a power of 2. And I'm going to keep goal history on because we can have intermediate goal histories, because water flow we do have the values there. Look ahead, I'll keep only as 1 because I only want to predict 1 step in advance. And then I'm going to hit submit. Now, this is going to take some time. If you are running this could easily go up to a minute of time, if your machine is slow, especially since we're running it on that. So I'm going to definitely leave that on there. It will take time, and we'll come back to this afterwards. So I can see Utkarsh is also working at the same time on that, which is fine. In the meantime, I'll just come back to signals and profiles. So you had seen, okay, it does actually give you the relative things about the fields, but by default, it does not create. So if I went here and I came to my property, again, all these things, if you want to see the parameters you've used, they will come in your model configuration. So it says I used a look back size of 8, I used a look ahead of 1, and I've kept goal history true. And the other stuff, I've just kept it by default. Validation holdout says that 20% of the data, this is the default validating. Okay, so we finished, and this is our, okay, and we've got pretty good results. So you can see it's a very low RMSE in both validation and training. And the Pearson correlation is very high. Of course, this is a data set that is sort of generated, so we do expect good results, but you can see everything falls within this. So this is a very good model. What's interesting is to see the model details. So unlike the previous one where we saw model details, we saw only individual fields, you can see the pivoted fields here. So instead of having just one field for water flow, it has an offset up to, since we said the look back size is 8, it has 0 to 7. And it shows you all the things. So all these values are being created, and all of these will act as features for our model, and they already have been. So you can see even relative humidity offset on that. Now, how do we score this data? So we know our model is good. We've seen the RMSE is there. We do some predictive scoring. And how do we do that? We go here. For predictive scoring, we go to new. I want to use the other data set that I had created, which I told you not to use before. We use water pump train.csv. We use water pump score.csv. Okay, so I'm going to submit that. And it's going to be brought into the system. And I'm going to score the data I have here against. So once we do that, I have to give it a name. So I'll just say, PS underscore pump model underscore NS. So we've got everything there, and the filter, I'm just going to use all data. I don't want to exclude anything. So I'm just saying it uses 1463 rows representing 100% of all the rows. So once I do submit, this will not be as slow as training the model, but it is actually running a windowed calculation on all of them, because remember, even within the training data, even within this data set, it is finding windows. In the meantime, we can also, oh, it completed, but I'm just going to bring up like, so we can take a look at the scoring data set. So you can see it's very similar. It's very similar to the training data set, the same fields, but it's also got a temporal ID and different things. So it is going to score based on these, and remember, it needs to have at least 8 entries because our lookback size is 8. So some of them might not have values, like, okay, in this case, it has 8 values. So each of them has 8. So it will predict 1 value for each, but it does have readings on there. Now, if we go back to our training, okay, so it's completed this. Now we can download the CSV, which is the results file, and we can take a look at that. And here it tells you for each, and of course, you can always join it to the other data. It gives you the predicted what you can ignore. Predicted water flow is just like _MO is just where it is kind of normalized a bit. So you can ignore that. The main thing is to look at this predicted water flow. And you can compare it to, if you look at the data set here. So these are the actual values. And if we look at, for example, let's see, it has created. So it's actually created models for, you can see it's generated a lot more records than are there on the basis, so it's created a full different thing. Like you can have a look and see how many it's actually created. Although we've only got 8 input rows, is generated all the way to 185 here from the output, and where it takes the underlying values and it scores on there. And you can compare and you can see the values where they go from 10.47 to 10.40. These values are fairly similar also. So you can see how it predicts the values based on the input that we've given as well as our model. So it's taken this and it has done that. And again, the beauty of this is that it works with all sorts of different data types. So we don't only have one pump, we have pumps with IDs 1, 10, and all that. And again, we can join this back on this system. So this is just a quick example of how this worked with, we're going to do one more data set. We did want to finish up by 6:30, but I will go over like one more data set. It should take us about 15 minutes, sorry, and just show you how that works with that. Now, our other data set is much simpler. I'm going to close this because we are done with the water pump data. You don't need to save this. This is again generated, so you would create that. Again, you please feel free to play around with the data once it's on there. Now, the second one that I'm going to say, you can see the description there, is we're going to look at the laser data CSV. Laser data is much simpler. It's only got one field. It's got one entity ID, which is just phasor bank, and it's only got one value, laser data. And the temporal field here is like 5,000, because I wanted to say 5 seconds, so 5,000 milliseconds. So its intervals are 5,000 milliseconds, so 5 seconds. Okay, so it changes once every 5 seconds. So we get a new value of laser every 5 seconds. So let me close this. And let's look at the metadata. Again, we have the temporal field here. And I've given a time sampling interval, as you saw, which is corresponding to 5,000. So that's 5 seconds. That's in milliseconds. And our continuous field is laser, and our entity ID is a field, but there's only one value on it. So it's very simple data, and it'll be useful for us because I'll show you how to actually operationalize also. So let's go back to data. Go through the same process. I'm going to call it laser data. I'm going to select the JSON, which is our metadata. I'm going to specify, I'm going to actually just do, we don't need to review the uploaded metadata. We know what it's going to be. So it's just going to submit that. It creates a job ID. So with the pump data, we only worked in Analytics Builder. We built up a model, and then we wanted to see what's happening there. Now I've got this. I'm going to go and create our model. So our model name, we'll call it laser model. This will automatically pick up laser. We're using that. We don't really need to. It automatically knows that it's time series. I'm going to set a small look back size of just 4. This, it's not important how accurate our model is here. So, we don't really need to worry about this too much. There are all sorts of things. You can also try with a redundancy filter. That's something else that's common to all models, not just time series, but we can just use this. I'm just going to do this, and I'm just going to hit submit. So this should be a little bit quicker. I forgot to suffix this, but you know what that means. So this is univariate in that it just has one field, and it'll just be easier for us to see how to operationalize this. One more thing is that, of course, this is real world data. It's not been prepared. Like the pump for data was tweaked a little bit, I'm sure, just to get details on that. So while I'm creating it and Utkarsh is also creating it, let's. So I used a look back size of only 4 just to keep it simple, and hopefully so it's faster, because we're not really bothered about the accuracy here. You can definitely practice with this and see how you can make it more accurate. Okay, there is completed. Oh, well, that's pretty good results. I mean, the RMSE is quite low, 3.62767. If we had increased, I mean, I've tried this with different look back sizes, it might actually reduce the accuracy also. So sometimes increasing the look back size could also reduce the accuracy, but you might get the results. So if you look, let's look at the model configuration. That's all the things that we set in. We've done that. Let's look at the model details. So now you can see laser offset. It's created different pivot table functions. So you can see it's got derivative one. So these are all mathematical terms, but it's just applied. But it's all taken from one base field, which is laser. So we are just predicting laser. Now, what we're going to do with this, unlike the water pump data, we're not going to predictively score it. We're going to operationalize this directly. So how do you start operationalizing? First, you have to bring it into Analytics Manager. So you go here and you click Publish. Okay. Once you click publish, a window will pop up which will tell you, that your model is published, and it will give you different options. This is where you enable your model. So make sure you click enable, and it will automatically do that. The other thing is also important for working under the hood, because this is how you incorporate all this data into ThingWorx Foundation. Because you want to work with normal things using that. So it gives you a model file URL, which you can use later on, like if you want to invoke it from services. It gives you data shapes also. It creates data shapes. So data shapes are basically descriptions of tables, right? So it creates a data shape. It creates an input data shape for your predictions. So when you want to get a prediction from the system, your parameters have to be passed in the form of an input data shape. So obviously, there's only one field, like its laser is there, which we will give as a number. And your output that is returned will be coming as a result data shape, which will come with a predicted laser value. And we are going to bind this to an actual physical thing. And of course, we have to create that thing still. So, okay, so we've created everything on here, and we've seen the model is ready. We've published it. We've done all that. One thing you'll notice also, first, let's check if our model is there. Yeah, it's there. Ignore that. Like last time I had called it concrete analysis provider. Provider is just is just something that you can use the same provider. It just maps over. If you look at provider here. So I had created something, I called it concrete analysis provider, but it was just a generic which uses the analytics server connector. So this is just something that you specify. It uses it by default. So don't worry about that if it says concrete analysis. So I'm going to enable it from here. Oh, it's already enabled. You can see the check mark on. So my model is created and my model is available in Analytics Manager. So it's ready to be operationalized. Now I want to create an analysis event, but analysis event has to be tied to a ThingWorx thing. Okay. So what am I going to do? I'm going to go back to things. In fact, like I said, there are different views. I'm going to use the project view, which is under my project. So if you are doing that, you should always use in ThingWorx, you can specify a project context. So you can see here where I've got plus, make sure that project context is set to assembly project. Then any new objects you create will automatically go into that. So if you haven't done this already, please do go here to go to the plus button and make sure, see if it's gone. Again, you just do an autocomplete, you say assembly project and make sure you select assembly project. So this should be set on, and then by default, it will be using this as your logic queue. Once you have everything, that is every item that you create will go into your project and it's organized here, then you can view everything from there. Okay, so I want to create a new thing for my project, and I'm going to go to here. Oh, no, that's for creating a new project. I'm going to create a new thing by clicking plus here. And I'm going to create a new thing. And I'm just going to call it, I'm going to give it a silly name like laser thing underscore NS. So this is going to be my data. That is, we are going to assume that this is the data that is coming from the sensor and is being modeled on here. So this is my actual, like my data model that I'm using in IoT, in ThingWorx Foundation, okay? You can see the project name gets automatically filled up here. Everything has to have a thing template. I don't have a specific template. I'm just going to call it generic thing, right? And that's it. I'm just saving it and I'm done. Now I need to create a few properties and alerts if I want to use it. So there are a few things. So taking, like if you look at our input shape, these are all the fields that need. So I need a causal technique and a goal field. Causal technique always has a value, and so I should add it as a property. So I'm just going to call it technique. I'll give it a default value where I'll say it should be full underscore range, which is again our value. So I'm going to create that. And I'm going to give another one, which is our goal field. And I'm just going to leave that blank. That doesn't really need anything. So these are two string fields that you need to add when you are dealing with string. And of course, I do need my, my value, my laser value as well. Here, I don't need to give a temporal ID. There will be a timestamp automatically adopted. I should click on persistent and logged. So persistent and logged data has history. So any data that is being written, if you are storing the history, not just the current value, it needs to be logged. So you can see the description. We've used this in the past. We need a value stream with that. A value stream is another object. I haven't created a value stream yet, but we will do that. Let me actually do that first. So laser is a value. So that means that even when the value changes, it'll still store the history of the value. So you will be able to access that. An important point that was noticed is I didn't have a value stream. Value stream is a physical space on here which stores the historical data. So when the values change, because your thing only stores the current value, so I only store the current value of laser, but if I want to store all the past values of laser, I need to specify a value stream, and we've used that quite often in the past. I haven't created a value stream, so I'm going to create a new one from here. I'm just going to call it a value stream, just a regular one. A remote value stream sits on the edge. We don't need that. And I'm just going to call it, VS or laser underscore VS for value stream. We don't have to do anything. This is just like setting a physical space on that, and everything else is the same. So we just have to create a value stream, and then we go back and we specify the value stream here. It automatically gets filled up. And now all our values, all our historical values will be written to that value stream, okay? So we've got a value, we've set the value, laser is going to be our input field. So that is the value field at that particular time, but we also want a prediction field, a prediction field so we can compare the two. So I'm going to have a field which I'm going to call predicted laser. Oh, one more thing. It should, I didn't change that. It should be a number field, by the way. It should not be a string. And again, I'm going to select persistent and I'm going to select logged. And that's done. In fact, I should change this. Laser should also be a number field. Okay. So it's number, it's persistent, it's all done. So it's logged. So we don't need to do anything else here. Okay, so we've got two number fields here. One is laser, which is going to be our input value to the model for the prediction, and one is the predicted laser, which is going to come back and get filled in. So how do we do this? First of all, we want to set up laser with dummy values. We don't use the values that we've got in our table. We're going to just use something simple, which we've done in the past. We're going to create a simulator. How we do that is by just creating we're going to create a thing called a timer. I'm just going to call it laser underscore timer. A timer creates events every n seconds. And the way we do that is by using a timer based template rather than generic thing. I'm going to use run it as an, this is not best practice, but I'm going to run it as admins so that, it's just so that my update rate, I want to keep it, this is again in milliseconds. I want to keep the update rate at 5 seconds. So every 5 seconds, I want my timer to trigger an event. And every 5 seconds, I'm going to fill that value automatically. So now when I come here, I need to create a subscription for that timer event in my laser thing. So I'm going to subscribe to that. I'm going to, by the way, you should check that it's enabled. So it's I'm just going to call it simulate data. And the source is not going to be the same entity, but another entity which we've defined, which is your laser underscore timer. And the input that I'm going to go is the event that it triggers every 5 seconds is the timer event. So every 5 seconds, and this is a global event. So every 5 seconds, the timer sends an event, and this function is called in our thing. So this way, the laser timer can influence laser thing NS, and we can do that. Now, what do we want to put in? We can put some simple JavaScript here. I'm only going to simulate the value of laser. So you can see the autocomplete also works. This is all JavaScript, by the way. I'm only going to give it a simple dummy value. This will not make for great predictions because it's just a randomized thing, but it'll show you how it interacts. Oh, I should just. So what this will do is it'll take 50 as the base, and math.random gives you a value between 0 and 1. And it'll just multiply it by 100. So you'll get values from 50 to 150 possibly, and just randomly on that. So this is just going to create that. So this will be called every 5 seconds because we subscribe to timer. So once we do that, I've already enabled the timer, but you can I've already enabled this, so it should be there. You can make sure your timer is also enabled. It is enabled. It's checked on, and this laser thing is there. Once we've enabled this simulate data is going to get called every second, and you'll start seeing values getting populated every 5 seconds. So these default values are getting populated every 5 seconds, and they're changing every 5 seconds. Also, because we have done it as a history, you can call a function called, there's a service called query property history. Let me actually just search it. So query property history. If I execute this, it actually shows you the values changing. So you get a history which is being stored in the value stream, but you can see with the timestamp as well as this. So if I execute it again, you'll see the values keep adding. So the historical values are also being stored, which is very useful for us. Now, what we want to do, our next step, now that we've set up everything in our laser thing, is we want to create the analysis event. So we're going to go back to analysis. We've created analysis models. We come back to analysis events. Let's create a new analysis event. Our source type is a thing, and we will use the thing we've just created, which was laser thing underscore NS, right? The event that we want is data change, and the property that should trigger that data change is laser. So every time the value of laser changes, this analysis event will be triggered automatically. So we don't need to come here and say, okay, do a prediction. We just use the default provider, the model name that we use. So you have to specify the model. This is the one that I published. Utkarsh has also published it, so I want to be careful not to use his. And done that. And you'll notice one thing, it automatically gets the sampling frequency from our data itself, as well as the lookback count, which we had specified from the model. So this is really something that is unique to time series. Once we say save, we've successfully added, but it's not been enabled. So I shouldn't enable it yet. I need to map the data to my thing. So where do I get my input values from? So the first thing to map are like my input variables from laser thing NS. So I need to do the inputs mapping. So I select thing. What I want is like when the laser value is, the laser value that is constantly changing, I want to map it to the laser for my input to the prediction event, right? So this is going to be passed to our prediction engine. So laser number underscore laser should be taken from laser in laser thing underscore ns. So I know there's a lot of lasers, but all this means is that the value from the thing, the real-time value, is copied into our input to our prediction engine. Okay, so I need to map that. So it does that. And then I also need to map our output. Remember, we're storing the output in the same thing. So the results data shape will return a value called predicted laser number, and I want to map it to laser number. To predicted laser number. Okay, by doing that, whatever value comes from the result, the analysis event runs, gets stored in the thing. One thing I forgot, in inputs mapping, I also need to map. Remember, we added the 2 fields, causal technique. So we need to map those also. So causal technique is mapped as well as goal field. The rest can be left as it is. Okay, once we've done this, all our inputs are mapped as well as our results. So it stores the value. You can see here that it goes to laser thing underscore ns predicted. And if I do this and I close the value, I'm done with this. Now I can enable my event. So now I've started my analysis event, and it will run every 5 seconds. Now, if I go back to laser thing underscore ns and I go back to properties, you'll see that the predicted laser values are getting filled up. And they will change every 5 seconds just as the input comes in. So we are generating the laser values, and it is generating predicted laser. You will see that the values are complete like rubbish here, but the main goal is to show you how it links in. So in real time, you would be like from your edge device, your sensors would be sending a laser value, and this predicted laser is what it should be at that time based on past values. If there was an actual thing, correlation, you would see that properly. So it doesn't matter if the values don't. So ignore that. But here you can see how our data model is getting results back from our. So just one last thing to do is like I'll just show you how to use a mashup to view this. In fact, again, we'll go back to the project. Let's create a mashup thing. Sorry, not a mashup thing, just a mashup. A mashup, as we've seen in the past, is just a web application. And here we're just going to call it, say, laser underscore mashup underscore ns. I'm just going to call that. Then I'm going to go to the design of the mashup. I'm only going to put a chart widget in the mashup. I don't really have much here. It'll just be a line chart. My line chart needs to be bound to some data. Again, as always, once you hit save and you view mashup, it'll automatically open up in a window. This would be what the end user would see. Right now, we've not bound anything, so our line chart is blank. We need to bind some data to line chart, which we will get from our thing, which in this case is, I think somebody else is editing at the same time. So yeah, okay. So we need to get the thing that we just has populated all our values. We have to use the same function, query property history. And we'll do that to execute on load. So that means the first time the page loads, it will call query property history, and all that data will be available to this mashup. Of course, we can also set it so that it refreshes. To bind the data, we just go to return data. You can see all the values under there. We're just going to click on all data and just drag and drop it to our chart. And it binds here. We need to specify a few properties, number of series. We're going to have 2 series. Yeah. So just make sure you set that. Our x-axis field is going to be, it'll show you all the fields in our data. We're going to select timestamp. And we're going to set data field. Data field 1 is going to be laser. And data field 2 is going to be predicted laser. So it'll just give us a comparison on that. Once we do that, let's refresh our mashup. Let's see what the rate values come in. So it shows you a time chart of everything. Of course, your predicted value only came up later, so it only started here. We had like all these. So this shows you all the charts. And you can set up a refresh here so that it automatically refreshes every time new data comes in. You can set up refresh according to the events. So this is getting data. So remember, predicted laser is coming from a prediction analysis event. So this is how we were able to operationalize our model, and we were able to. Obviously, these readings don't go into that because we've just been, the main key is that you can see the values. And you can see it's still extending more as the analysis event. Another thing you can look at, like if you go back to analysis, you can see the analysis jobs going on. All the analysis jobs, all of them cover under there, like, so you can see all the things, so wherever it's completed. Each of these corresponds to one prediction made. So, if you filter completed jobs, it'll hide all of them. But, as the function is running, it'll keep on adding on more. So this is where all the data comes in. So you can definitely look under the hood. So that's about it for this session. This is everything we wanted to show you hands-on. Sorry, we have run a little bit longer than expected. The last thing I'm going to do is I'm actually going to, like, you can of course play with this data, but I'm going to also upload some other data set. You can definitely see, there are some other data sets to play around with. Let me see if I can find which one should I show. Okay, again, I've shared all of these, so if you are interested, you can definitely, I'm going to share a gasoline prices data set, so you can play with that and build models for that. That's also got a metadata. Let's make sure I check off time series data. So I'm just going to submit that data. I'm not going to create them, the things. You can see the fields here. You can see what to do. You can do predictions based on things related to that. Oh, some error with that. Okay, it's not, I have to correct that. So let's ignore that data set. There was another time to, yeah, this is the one we can use. This is a transformed data set for time to, this is a bit more complex. It's actually taken from a, just call it TTF data. Okay, there are some issues with the data set, so we can ignore this. This is not really important. But anyhow, you've seen now how we can work with data sets. So you can take a look at like the different techniques we have to do, as well as how we can set analysis on there. Please do feel free to ask me questions. I'm going to stop sharing my screen now. So that's about it for our session. I hope we've covered a little bit more ground. Again, this is probably a continuation of our previous predictive analytics workshop. So if you haven't seen that, do have a look at that. Some of the topics were repeated, but of course, before you do time series, you want to see how the basic thing works. So the system is going to be online. Your usernames and passwords are still going to be online until the next workshop. So you can keep practicing with this data. Feel free to import your own data. I will be, like, of course, checking back on the server. If it gets too packed up, I will delete from there. So don't delete, but please try creating different things. It's very important to try to operationalize data also. So it's not just about building models, which you can do in other software also. ThingWorx allows you to perfectly see, bring it in with IoT data. So that's a very important skill to learn. And it's something that many people are using now, like you notice, you saw FlowServe as well. Great, that's about it for the session. We will announce our next session shortly. So please do give us your feedback and do join in. Thank you, everyone, and have a good day. Bye-bye.